There we go. Now recording. Now you're trapped. Ha! So, assignment 2. Assignment 2 was published just a few short moments ago. You now have access, so I'd like to take this opportunity to go through it with you so that you have some idea what the expectations are. So, the assignment is, roughly speaking, vending machines in a break room. We are going to produce a model of this situation in Java. So, this assignment is all about objects, which also happens to be the subject of the lesson today. We will be discussing objects, instance variables, methods, and encapsulation. All topics we are covering this week. The point is to create 2 classes to simulate a quote-unquote break room containing 2 vending machines. In graphic applications, or in programming in general, it is very often the case that we separate the quote-unquote model from the view. That is to say, the logic which underlies the program is separated from the logic that displays values in the model and interacts with the user. One way of thinking about the model-view separation, since I know most of you are probably taking JavaScript at the moment, in web design, you can think of your web page as being the view, right? And all of your server-side interactions as being the model. This actually, in web design, this gets extended with one additional component, which is the controller, so that the controller routes information between the model and the view. This is the quote-unquote MVC architecture, which I'm sure they will be talking about with you, perhaps a little bit in JavaScript, but they'll start hitting you with it more heavily in PHP once you start doing server-side. So, in our particular case, right, the model is a vending machine singular. We will create a class, or you guys will, for the assignment. You will create a class to represent vending machine operations. The view, you can think of that as being the break room. The view is what is interacting with the user. So, this is where the main method is, right? This is where all of your print statements will be. If you are doing the assignment correctly, the model contains 0 print statements. Why? Why would we not have print statements in the model? Excellent question. I'm glad I asked. The reason that you have no print statements in the model is print statements are user interaction when you're talking about a command line program, right? All of the interaction with the user should be routed through the view rather than the model. So if you are outputting things to the user from the model, this is technically incorrect, and I will be grading for that to make sure. Yes?
Are there any exceptions to that, like errors or things like that?
So, in general, so there are actually 2 output streams, right? You've got system.out in like Unix language. You're talking about std out, or standard output stream, right? Then you've also got system.error, which corresponds to standard error output stream. So in a typical command line interaction, you have both standard output and standard error, right? This one is, in theory, for your user interaction specifically, right? This one is only for errors. So technically speaking, you should be outputting all of your errors through system.error rather than system.out, which does not constitute normal user interaction. So I would say for the model, if you want to produce errors, like proper program terminating errors, right? You can use system.error for that because that's what it's designed for. Does that make sense?
Yeah.
Good. Technically not a requirement of this assignment to do that, but if you wish to impress me, then you can do things properly this way, if that makes sense. So, yes. Another good reason to separate out the model and the view. It allows us to take the model and plug it into other different views. We can take this class, throw it out, replace it with, for example, maybe something a little more graphicsy done in JavaFX, right? We could replace the view with some other form of view. We could even replace this with a web page, in theory. That would be a bit more complicated, but Java can be used as a server-side language. It's a truth about servers that actually any programming language can be a server-side language. It's just a question of, how easy is it to use for that purpose, right? But in theory, any Java model that you come up with could be assisting in the modeling of a web page at some point somewhere. You just have to build a different view and a different interface into it. But anyway, and this assignment is going to be so short that I don't know how much value you would gain from that versus re-implementation in PHP or something, but it's all up to you. But anyway, so do you feel like you understand the difference between model and view here? Because this is actually a reasonably important component of the course. It's something that you're going to see multiple times in multiple assignments. There's an assignment later down the track, which is essentially take one of your old assignments of your choice, I believe, and then implement a JavaFX view for your old models, right? If you have not properly done model-view separation, that's going to be a little difficult, right? So, good. So, step one, design the classes using the universal modeling language. Don't worry about the fact that we haven't covered that yet. That's part of what we're doing today, is covering UML diagrams. Okay? You can also call them class diagrams. So, the first step is to create a UML class diagram to represent a vending machine. Note, you create your diagram, then you program. You design before you implement. You don't go forward with the coding before you've done your design and then post hoc make your initial design document from the implementation that you've already made. The whole point of designing things is that you design it first, right? You're supposed to do the prep work before the stuff that you're getting to afterwards. Prep work comes first. So making the UML is prep work, all right? You can tell I'm speaking from experience, right? From marking a lot of assignments. So, So there are a couple of pieces of software that you can use to design your UML diagrams. Part of what we're going to do this week is we're going to make some diagrams using the software, so don't worry about it too much just yet. So, we are going to keep our vending machines very simple. A vending machine contains a single product type. The product has a name and a price, and there are a limited quantity of them available. So, when you select vend item, you get one of whatever item is in the machine, and the quantity of them is reduced. And if there are none in the machine, none can be vended. That's the type of basic logic that we're working with this assignment. It's mostly going to be if statements, not too much on the loops side, unless you count like the main interaction loop in the view, which, that does count. So, the vending machine tracks its currently unused credit and the total amount of money it has taken in since it was switched on. So, an operation on a vending machine is insert a coin or insert a quantity of money. It keeps track of its current credit. You select vend, it reduces the credit by the amount of the item, stores that money in its amount of money earned or amount of money taken, and then vends the item. Does this make sense? Hopefully? Good. The product name, price, and quantity can be set when the vending machine object is created, or the object can be created with default values for some or all attributes. We will talk about how to do that. That's encapsulation, the encapsulation portion. A user can put in loonies, toonies, quarters, nickels, and dimes into the machine. These are all denominations of Canadian coin currency. You should be able to get, okay, I'll just write it down. Toonie is equivalent to $2. Loonie is equivalent to or worth $1. Quarter is 25 cents. Dime is 0.1, 10 cents, and a nickel, which is a coin named from the metal from which it's minted, is 5 cents.
50-cent piece that's no respect.
Now, well, to be fair, they don't put very many of them into circulation. So, also, moment of silence for our fallen brother-in-arms, the penny. That's long enough. It's a very small coin. So, vending shouldn't be denied if there is not enough credit in the machine, or if there is no product left. It is up to you how to handle the user's change. So the user should receive change if their available credit is greater than the amount of available credit. Like, if the amount of the transaction is less than the available credit, the user deserves some change. It's up to you how to handle that. There are some suggestions for you there. Very good. When the machine is first turned on, by that we mean when the class is initialized, when the object is created. It is initialized with the name, price, and quantity of the product it contains. This is telling you how to create the constructor for the class. Class constructors are something we will talk about. They can insert money before they press the buttons, after they press the buttons, or while they are pressing buttons. There should be a toString function that returns a full, that should say method, that returns a full report, something like, vending machine, 8 chocolate bars left, price of chocolate bar, amount of credit, amount of balance. Important basic rule number 1, the vending machine is the model, that is the brain of the actual vending machine. The model should never talk to the user, it should do no input and produce no output in terms of user interaction. Instead, it should operate only through method calls. It only does something when a method is called. Is this making sense so far? Any questions? Okay. So, this is a functional description of the model. You must use it to produce a UML diagram representing the vending machine class. Step 2, actually implement the thing. In theory, this becomes easier once you've done the design, so do the design first. Once the class diagram is finished, implement your vending machine code in Java. Then write a main method in a different class, probably call it break room or something, to simulate a user interacting with machines in a two machines in a break room. This method should create 2 vending machine objects and allow the user to interact with each one using a menu interface. It's up to you how you structure this, but one possibility is shown in the example below. So this is an example user interaction. This is an example of what the view may output, right? So, you are not required to have your vending machines conform to these values. Please do not initialize your vending machines to be this precisely and exactly. This is only an example for one specific arrangement, you know?
How many vending machine objects we are creating?
2 vending machine objects. This is a very, very, this is a crucial part of the assignment actually, is understanding this part. The problem that a lot of people have at this level is that they don't necessarily understand the distinction between the vending machine objects and the view class, right? You have one view, which, call it break room. It needs to create 2 vending machines. If I see anyone creating the variables for these 2 vending machines inside of the break room class, you're probably going to fail the assignment. This is the very, very important entire point of the assignment, is to understand objects. If you're taking all of the contents here and you're copying it here, like copying the methods, copying the subroutines, copying the variables, copying everything, you are doing it wrong. You are doing it so wrong that I have difficulty passing you. That's how wrong it is. All right? The whole point of objects is that you don't have to do that. The whole point of having an object is that you can take this code and duplicate it without having to copy it in here and rename your variables, product 1, product 2, product 3. Price 1, price 2, price 3. That's like the whole point is that you're not doing that, right? So, be forewarned. Pretty much the whole class is here, so if anybody's not here, pass that warning along to them. If you must use objects properly for this assignment. Grumble, grumble, grumble. Professor is grumpy. So, important basic rule 2. The main method is the view. It talks to the user, calls appropriate vending machine methods in response to the user's input, and displays the results. It does not determine the results of a user's action or keep track of money. That's the job of the vending machine object. So this is reinforcing what I was saying before. The purpose of the break room is not to hold the money. The vending machines hold the money, right? All the break room does is provide an interface whereby the user can insert coins. Now, for our purposes, we are not modeling a user. We are not modeling how much money a user has. Basically, for the purposes of this program, all people who have a keyboard also have infinite money. So basically, you can create money by entering how much money you are entering into the machine on a keyboard, and that makes money for the purposes of this program. It'd be nice if that's how it worked in real life, right?
I'm pretty sure that's how the federal government does it.
Ho ho! Sick burn.
What do you think inflation is, like 2,000%?
Haha, yes. Indeed. So that's all true. Encapsulation and documentation. Make sure to encapsulate your instance variables. Don't worry that you don't know what that word means yet. That's again something we are covering this week in class. Basically, it means making variables private and accessing them through methods instead of making them public and accessing them directly. That's the short summary. To hand in the assignment, you have to do the same thing as last time, take the Java source code files, make them .txt, submit them through Canvas. Also, the documentation standards have changed. Since we now have classes and methods, and this is a bit more than it was before, we now have different documentation standards which apply. So, number 1, all classes must have JavaDoc documentation. The author tag must be there and must be, your name needs to be there, right? If I see anybody write Sam Scott in there,
Oh, I might just do that.
Secondly, these are instance variables. All instance variables require a one-line description in JavaDoc. Next, these are methods. Every single method requires documentation, no matter how short. You notice that these are quite small, these methods. They still need to be documented. Okay? And then, of course, for anything that's like sufficiently long, inline commenting is also preferred. You don't have to comment every line, but commenting is good. It's not actually true that the more commenting you do, the better. The correct approach to commenting is you explain what the purpose of a piece of code is. Since you're commenting source code, you can assume that whoever is looking at it knows enough about the code to be able to find the comments in the first place. You should not assume that whoever is reading your comments is incompetent in reading Java code when you're commenting in Java. This is a long way to say there's no need to explain how the code, like how the language works in your own comments, unless you are doing so for like self-studying purposes, right? If you're doing that because you yourself are learning how the code works, that's one thing, right? But a simple explanation of, a restating in English, for example, of what the lines of code are doing, that's not. You're kind of just wasting everybody's time, because anybody who knows any Java can get that just by reading your code. The point of comments is to give people things that they can't just get by reading your code, which is like what you were thinking. Why did you name, why are you using this variable? Sorry?
You want to document intent as opposed to
Yes. How the language
restating
works.
the model. And
Yes. Yeah, exactly. You want to document your intent with the design. Absolutely. Yeah. Does that make sense? It's kind of like there's this famous quote from Churchill. I apologize, this letter is so long, I had no time to make it shorter. That's like people when they're writing, and like writing comments is writing in a general sense. People have a tendency to write too much, and then like through the process of editing, you sort of make it smaller and more compact and, distill the idea down, right? That's kind of the same idea here. If there's more comment on your page than there is code, you're probably doing something wrong, right? Not terribly wrong. Like, it's still better to be commenting than to not be commenting at all. But, you should be shooting for, just kind of have respect for the reader's time, But anyway, I'll stop talking about it. Any questions about the assignment? Okie dokie. Well, we've got a lot to cover this week, so we might as well get right to it. Object-oriented. Object-oriented. Gesundheit. So, object-oriented programming. A term you will have heard quite a lot. Perhaps you have a fuzzy idea of what object-oriented actually means, though you probably know, like, C++ is an object-oriented language. Java is an object-oriented language, right? So, the object-oriented paradigm is so incredibly popular among sort of baseline programming languages. Pretty much every modern programming language that you're likely to use has object-oriented constructs in one form or another. So, we are not so much talking about a different form of programming, but using the existing programming you already know properly, right? There are a few languages that are not object-oriented. All right, class, what's my favorite programming language?
Python.
No! What's my favorite language?
C.
C. C is not an object-oriented language. In C, the level of abstraction stops at functions. You can package variables up into clusters of variables called structures. You have functions available, but that's where the level of complexity stops with C. And this is why C has so many successor languages. If they had built object-oriented into C, we wouldn't need any other programming languages. That's my dubious claim for this class. So, notice the term I used was level of abstraction. right? Abstraction is a difficult concept, but as programmers, you need to have an idea of what I mean when I say abstraction, all right? Most of the things that you've been working with in programming languages so far are abstractions, all right? The concept of a variable is an abstraction. What is it an abstraction of? CPU memory operations. The programming language, or the compiler, will compile variable operations to loading and unloading registers from your main memory. These are operations that you no longer have to worry about. They're being done by the compiler. You can think in more abstract terms. You can think in something a little closer to algebra from math, right? That's the purpose of the variable, is to hide a bunch of complicated memory operations from you so you don't have to worry about them. You don't have to worry about the fact that when you put a variable on the right side of an equality or an assignment statement, that's implicitly loading something from main memory. You don't have to think about that. You can just say, x is equal to 5 plus y, and then it just works, right? You don't have to think, okay, loading main memory address 3274, adding value 5, that's an operation, storing back in address 237. You don't have to know that. All of the actual memory addresses for the variables are hidden from you. This is the process of abstraction, right? Many things in programming languages are abstractions. If statements are an abstraction of gotos, as we've previously talked about in class, right? Loops are also a type of abstraction from gotos. Functions, or methods, because this is Java, functions are also a means of abstraction, and quite a powerful one. What a function allows you to do is it allows you to take a series of instructions and repeat them several times in the code, changing parameters, right? So you can parameterize a piece of code, a chunk of code, and call it several times in several different places. This is a very, very powerful abstraction method, and one of the key developments of early programming languages like Fortran. So far I haven't said anything about object-oriented though. So what is object-oriented then? What are we abstracting? Object-oriented allows us to take functions and combine them with the data they operate on and package them up into a neat little bundle that can be dealt with as an interface. So, you've all heard the term API, I presume? Application Programming Interface. In Java, we consider classes to have an API. The API of a class is the collection of public methods that the class presents, which can be called by other objects. So, when we talk about the vending machine, and we say the vending machine's values should be accessed only through methods, that's what we're saying. It means the vending machine should be accessed only through its API. The API which you yourself are creating. Good. So, it's important to know that object-oriented is a layer built on top of procedural or imperative programming. The way that you folks used Python previously, there's no distinguishing that from an imperative language. You basically were not using it in any more complicated a manner than you would have used C, right? Python does support object-oriented constructs, but they're bad because Python is bad. It's another reason that Python is bad. I can show you some stuff about Python and how it does classes. Ask me to show you how terrible Python's class system is about 4 or 5 weeks from now, and then maybe you'll be able to appreciate it. But we're not there yet. It takes experience to know how terrible Python is. All right? So you do not throw away procedural thinking. That's what goes in the methods now, right? We are finding a place for our procedures. But by using object-oriented programming correctly, our procedures will become vastly simplified. Most of the methods that you write in this class will be small. They will do single things. They will encapsulate simple pieces of logic. And the whole point of object-oriented is to combine those pieces of logic in, useful ways. The one exception to this is when you're running a command line interaction, where it's like choose an option, that type of thing. Those tend to get long just because there's a lot of talking back and forth to the user in it. But the logic itself should be in the layer underneath. We'll see how it works. So let's take, for example, the game of Pong. Hopefully most of you are familiar with the game of Pong. Very simple early video game. Earliest versions were called Tennis for Two. So if you were to write a procedure for Pong, it might go something like this. First, you clear the screen. Second, update ball position. Then update paddle positions if user is given input. Fourth, draw the screen. Fifth, detect ball collisions. Sixth, change ball direction if necessary. 7, update score if necessary. 8, go to step 1. Something like this, right? Procedural, do this, now do that, now do that, now do that, now do that. In Java, we ask different questions. We think of a program as composed of sub-objects, each of which has its own behavior. So, of this Pong game, what sort of objects do you think we could implement for it?
Paddle.
Paddle? Yep.
The ball.
The ball? Absolutely.
The game area?
Field of play? Sure. Yep.
Score?
Score? Yep. There needs to be some kind of score-keeping mechanism. Absolutely. And the one that isn't obvious but you would need anyways is an overall game controller, right? Because classically in Pong it's like whoever gets 10 points first wins, right? So you need something keeping track and watching to see when a player gets 10 points and then interrupting the game when that occurs and maybe saying, you win, something like that. That's the purpose of a game controller. The game controller might be the thing that resets the ball to the middle when a point is scored, that type of thing. So you need a top level of control in addition to all of the subcomponents, right? In the context of our assignment 2s, that's the game controller is more similar to the break room type idea, but I wouldn't go to the effort of separating model from view. In game programming, it's a little different, but we don't have to get into it. So, Good. So, let us discuss the difference between classes and objects. We are learning object-oriented programming, that is, programming which is oriented towards objects, but I've been using this word class quite a lot. So what is a class?
It's what you construct an object from.
It's what you construct an object from. Correct. What is an object?
An instantiation of a class.
An instance of a class. Yes. So, there are several ways we can think about this. Number one, the difference between a class and an object is the same as the difference between an integer and a variable of type integer. Right? So in one case, you have the data type, integer. We know what an integer is conceptually. It's a whole number from negative infinity to positive infinity. In a math sense, at least. In Java code, it's limited by the size of the data type itself. So it's whatever subsegment of that fits inside 32 bits, centered at 0. That's an integer. That's different from integer x, which has a current value of 10. Right? The variable is an instance of the integer type. In the same way, an object is an instance of a class. When we write a class, we are creating our own custom data type. This is actually true. You can use the class name as a substitute for a data type when declaring a variable. That declares an object reference to an object of the type specified, or to an object of the class specified. Classes and types are very, you can almost interchange the words, but I'll try to be rigorous about it. Does this make sense?
Yes.
So far, so good? Good. So, question?
So the class is the type, and then the object is the variable thing.
Yes.
Okay, cool.
That's, yes. So, we must now ask ourselves, what are classes composed of? What makes a class? Two things: data and operations. Data comes in the form of instance variables, or fields, but I'm going to use the term variable. Procedures come in the form of instance methods. We aren't really going to understand the difference, like, if you're wondering why I'm calling them instance instead of, class variable, etc., there's a distinction that we are going to draw later in the course between instance variables and static variables, but we aren't there yet. But the terminology is nevertheless being established. All you need to know, for the time being, instance variables are variables that are actually created in the objects, whereas static variables are not created in the objects, but we don't have to worry about static just yet. But if you're looking, semantically, if you're looking for opposites, the opposite of an instance variable is a static variable, and static is the opposite of instance. Question?
Is there any difference between instant variables and attributes?
No, those are both the same thing. Part of the problem with object-oriented is there's no harmonized set of names that they give everything. Each language likes to call things slightly differently. My personal preference is for the C++ terminology. I think that makes the most sense. But since we're learning Java, I must use Java terminology. And the Java terminology is instance variable and instance method. In C++, they call them member variables and member functions because they are members of the class. I think that makes a little more sense semantically, but it is what it is. Yes?
So the string object, is the string object also a string class?
Well, the string class is referenced anytime you say, string dots and then you call a method, right? When you create a string x is equal to hello, you are creating a string object, right? String is the class, x is the object.
So if I did x dot something, I'd be referring to the class of the object, not the object itself?
The class provides the definitions to the object. There is a difference between calling a method from the class and calling a method from the object. You can only call static methods from the class itself. Everything else requires an instance. That's why it's called an instance method. So if I were to say x dot equals, right? The correct way of thinking about this is that the equals method is being run on this object, not on the class,
Okay.
right? So does that make sense?
So when you're saying string dot at the top, like you mean like if I just put like colon hello dot something, that'd be calling the class off?
No. So there are certain. We're kind of jumping ahead of things a little bit, but so when you specify something as static, that attaches it to the class rather than the instance. So, for example, if we had a main, I don't think string has a main function, but if it had a main method, for example, no matter how many string objects are created, there's always only one main method per class. And that's referenced through the class itself. That's what it means to be static. Instance methods are used on the objects, right? They apply to the objects. You actually cannot call an instance method from a static context because it requires the information contained in the object. This does not contain instance information. This contains instance information. So, if we were to try to call dot equals on the class, it's like dot equals what? There's nothing stored in there, right? Only static members.
Yeah.
For this, we have an actual x, we have an actual value that's stored in there, so it makes sense we can do equality comparison on it. Does that make sense?
A little bit more. I'm going to look into it on my own.
We also have material on it coming up next week. Yes?
So dot equals, or equals exists someplace in string.
Yes.
So I could go inside string and alter equals if I wanted to.
Yes. You could go into the class, modify the definition of the
How it
method,
works.
and it would apply to all instances everywhere else in the code. That's part of the power of the abstraction mechanism. Remember that one of our design principles in code is if we have to change something, we want to be able to change it in only one place, right? We don't want to have to carry a change through in 20 different places in our code if we can help it. Yes?
Okay, quick yes or no. The class is the blueprint for a house, the object is the house.
Yes.
Great.
So, for the time being, we're going to leave the issue of methods alone and just create some classes which contain only variables. All right, we're going to start off with variables. So, consider the following Java code. Public class circle. We have 3 instance variables, radius, x, and y. This is a class. Let's open up IntelliJ if you haven't already. I will show you how to do this. Unfortunately, I can't make the sidebar any bigger. It's not in the interface for me to be able to make it bigger. So, in the back row, if you could just squint or come forward if you need to see it. But to create a class, I right-click on the source folder, New Java class. You will have done this a few times before, but before we didn't really mean class. We just meant something I can dump some code in. Now, we are thinking about things properly as classes. So, let us create class circle. Press enter. Our class circle has been created. Now, you will notice that there is no main method here. We will not be creating one. The main method should occur in the top level class, the class which is actually being executed. This is the class that instantiates all other classes. That's the, top level is the way to think about it, right? The convention in Java is that other classes may have main methods, but if you have a main method in a class that's not the top level, the purpose of that main method is to test the class. That's the Java culture for what the purpose of a main method in a non-top level class is. Most of the time in most programming languages you wouldn't see one. Alright? Is this making sense? It's just, if this is a Java class, you should learn a little bit about how Java people think about Java, right? So, let us now add our instance variables. Public double radius equals 10. Public double x equals 100. Public double y is equal to 100. Don't worry too much about the public keyword. We're going to get into what that means once we talk about encapsulation. But the opposite of public is private. So this is not universally case. There's also a protected keyword, which is somewhere between public and private, but don't worry about that too much. Public means it's accessible to things outside the class. Private means it's not accessible to things outside the class.
And
But-
in assignment 2, are we using public for most of the things, or are we using private?
For the time being. In assignment 2, it says to encapsulate your variables, which means make them private. So, to encapsulate something means to, put it in a capsule, to draw a boundary around it. public variables can be accessed directly from outside of this class. Therefore, there's no fence around them.
So they're kind of global?
It's not quite the same thing as being global. All of these variables are global to all of the methods in this class, but outside of this class, they are not global.
Okay.
Outside
So
of
they
this
can't
class,
be
you need an
accessed-
object reference.
So they can't be accessed for the other class?
They can be freely accessed by other classes, but they're not global variables because they're bound to a local instance.
Okay.
Yes.
So in the main method that's gonna run circle, I can change y by saying circle.y equals whatever without running a method.
Precisely so. Let's do that. So let's make a new Java class. Let's call it main. The convention for classes is that they should be capitalized. The names of classes should be capitalized. Can I do side by side here? Split left, right. There we go. Yeah, there we go. Perfect.
How'd you do that?
Right click, split right. There we go. So,
Right on, thank you.
in our main class, this is the class that's actually going to execute. In order for any code to actually be executed, what is the entry point into a program?
Public static void main.
Public static void main. Our shortcut, once again,
String array args.
type main, press tab.
Enter what's the
Yes. This is a thing that can actually execute. Now, I'd like to point out something, it's going to be hard to see, but nevertheless, in our menu, or in our hierarchy view here, you will see that one of these classes has a little play button on it, and the other one does not.
Yes.
The method, the class that contains a main method says it's executable by having that little play button. This one does not have a main method, therefore it's not executable, therefore no little play button. Does that make sense? Question?
What is the meaning of having those square brackets beside the string?
Oh, that means it's an array of strings. Yeah.
Don't try and
So
understand that.
arguments is going to be the whatever we can have multiple arguments?
So it's okay. I'll explain it. I'll explain what string array args means quickly.
That's just the incantation you need to utter before every program.
So you have to kind of think about it in a command line context. So if you were
Just need to
calling
type
this
name,
Java
then press
program
tab.
from a command line, right? Which fundamentally that's how all operating systems do work under the hood, even if like the GUI is hiding that from you, right? Like if you go in
It's all
with
still
even in
DOS.
Windows, if you go in and make a shortcut for an executable, you can change the flags, right? That's changing the command line invocations for a Windows program. You can do it even in Windows. So, but Bash is the best, so I'm going to do Bash. So, if we have Bash prompt, this is the most powerful symbol in all of computing because that is the Bash prompt. The line which runs Java hello.class. I suppose in this case it would be main.class, but whatever. Then, something 1, 2, 3, right? With spaces in between. What args does is it says, this is args at 0, this is args at 1, etc. I'm not sure that might start them here. that might be the case. It might be args 0, 1, 2, 3, 4, and 5. But anyway, the whole point of args is to be able to grab command line parameters that are put in, like in a bash prompt, or like what the flags the program is being run with are. We are not really like we're never going to actually use that in this class, so you don't have to worry about it. But that's what it's for. It's for args is information passed to the program by the operating system.
And do we ever need to pass any information to the main?
Not in this class, but you will find in your actual real life that is, there's really, it's a really, really strongly helpful thing to be able to do, especially in Bash. Like, the whole way that Bash works is by passing things in a command line. It's like if you're doing any Bash scripting at all, like it's an absolutely essential operation to be able to do that.
So what kind of things do we pass in general?
Oh, okay, here's an example. Your Java program does something with a file, right? Which file? You pass in the name of the file, and then it does something to that file. Does that make sense?
Yeah.
That way, if you, for example, want to run this program on every file in a directory, you just grab them all in Bash, run this on each of them one by one, and hey presto, you're doing batch processing, right? And if there's one thing that you should learn to love, it's batch processing. Batch processing is the best. It's the best thing that you've ever done in your life. It's so satisfying. It's like, I will have my robot minion do this for me. It's like, my God, there's, like, my wife was doing this thing where she was, like, pulling images off of, like, iCloud storage because, we have 2 small kids, and her mother is constantly demanding photos of these kids, right? And it's like, she generates quite a lot of photo traffic, right? So she's, like, downloading them all off of iCloud into local storage, which is not something they really like you doing. So they kind of make it difficult for you. You can only pull like 100 images off at a time and stuff like that. And I'm like, man, that would be so easy to batch process. Like, if there was a command line interface, it would just be like, yeah, run it once. It just does it in the background, pulls all the photos. It doesn't matter that they only let you take 100 at a time, because as soon as that one's done, you just do the next 100. And you don't even have to do it. It just does it, But anyway, it is generally my opinion of computers that only like 1 in every 100,000 people are actually using their computer to like the full effect, like fully utilizing the power of the machine they have in front of them, But, and I don't even include myself in that 100,000. I could be doing it way better. Everyone could be doing it way better. But anyway, what were you talking about? Oh yes. So, in the context of assignment 2, model, view, vending machine, break room. Okie dokie? Good. So, you can't just use circle, right? If I was to say something like circle.x, you'll see that it's giving you an error. Make circle x static. This is this problem that I was talking about with you, sir, at the back of the beard. This is that problem. You can't access this. It's an instance variable. You need an object to access it. This is attempting to just sneak in through the class name, right? What you need is a declared object. circle C is equal to new circle. This line declares an object. Technically speaking, it calls the constructor.
I was just gonna ask about, naming conventions for the object, but you have it in lowercase, so that answers my question.
Yes. So yes, object generally will appear in lowercase. This is to distinguish them from the classes, which are uppercase. You will find that Java itself follows this convention. Did you wonder why int is lowercase, but string is capitalized?
Strings are class.
It's because string is a class.
So int is not a class?
What?
So
No,
is
int,
not a-
int is a primitive, not a class.
Okay.
Not everything in Java is a class, which is one of the reasons that I consider it a sane language. Python considers absolutely everything to be an object. Absolutely everything, even like just like the number 5 is an object in Python. Yes?
Can you explain what circle C means again?
Yes. So, in detail. In the same way that I declare a variable of any other type, the first thing you do is you say what the data type is of the thing you're creating. In this case, that's a circle, right? The next thing you do is you pick a name for the variable. In my case, I chose C to stand for circle, but you could choose anything for there, that's your variable. Make sense? Next, new circle is the equivalent of the 5 here, right? We are creating a new object of class circle. The new keyword specifies that we are creating a new object. Circle specifies the class that we are creating the object of. Later on in the course, we'll see these do not necessarily have to be the same class when we get into polymorphism, but we don't have to worry about that just yet. The round braces indicate that this is running something. That's true. It is running something. What it's running is the class constructor. We haven't talked about constructors yet, but don't worry, we will. Basically, the constructor is a special method that is run only when the object is initially created and at no other time. Does that answer your question? Perfect. So, now that we have our circle object, we can perform read and write operations on instance variables which are public. I can, for example, print c.radius. Notice no errors this time. c.radius is equal to c.radius plus 5. S out c.radius. Just do some basic math stuff. There we go. Save, save, save. And right click, run main, running. Loading. It seems to be taking a while. You can see I've got 2 warnings here, but it's just because I'm declaring X and Y and not using them. So that's, you know, as warnings go, I don't care. It's very strange. Oh, what a pain.
Oh, that Windows based software.
Okay. I'm gonna show y'all something else.
Your systems.
While we're waiting for IntelliJ to figure its life out, I'm gonna show you something else.
It took me 27 years, so
Eh. But you did get there in the end, right?
we'll see.
Yeah. So I know it says Python, but don't worry. Yes. So this is Python Tutor. I don't think they show you this in like,
Our
Python,
teacher
did they?
did.
Did
He
they?
mentioned it.
Okay, but you've never actually seen it?
Oh yeah, I used
Okay.
it a lot. I learned a lot of Visualizer. It's
Fantastic.
an amazing tool.
So this is a really, really, really solid tool for understanding how code works because it allows you to step through the code one line at a time and actually view how memory is changing. Obviously, we're not going to do it in Python mode. Fortunately, it has a C mode, but for this class, it has a Java mode. The joke is, I love C. Yeah, Python's the worst, C is the best.
I'm
So,
sure there's something worse
Java's
than
in the
Python.
middle?
Java's, yeah, it's like option 2.
There's worse codes though. Ever heard of Arnold C?
Have you ever heard of Dreambird?
No.
Go look up Dreambird.
Look up
You
Greenberg.
Just deliberately
It's Dream, B-E-R-D.
malboj.
So, get AI help. I don't want AI help. Get out of here. So, basically, you enter Java code into this thing, it executes it, and it shows you how the memory is structured. Excellent visualization tool. The only limitation is that you can only put in so much code because it's, it's doing a really fancy compilation here. It takes time, but let me show you how this tool works. So I want my class circle in there. Class circle, there we go. I want my class main in there. Main, there we go. Your code is running. Oh, main is public, should be declared in the file main.java. Okay. How did the example go again?
Looks like what you did.
Mm.
Other classes do extend course.
No idea what you're doing. You don't need the string and line part to delete that. Just say that right there. Yeah, it's just
You just type Python and it'll be
Oh, Java, yes. Java, yeah.
I think there's something wrong right here. Red line part. Yeah, there's something wrong here as well.
Oh, maybe it's.
Yeah.
Does it want this one first?
Yeah, 'cause
Like,
you got it, yeah, you have that static.
No, the example didn't have the name.
Doesn't fix it, but yeah.
maybe it's like, it's complaining that this one's public? Yeah, okay. So, Java Tutor expects the only public class to be the one with the main method in it.
And is
So
the class circle
Here.
private then?
Actually,
No, it's just.
no, not private, just like unspecified.
Okay.
I think it defaults to protected
yeah,
actually,
you can,
but that's okay.
you can just do
So-
this out and you can-
You'll notice a couple of things. Number one, you've got this little slide bar here. This is your code. This is your code executing. All right. You can click through one at a time. Get out of here, you. And you can see this little red arrow shows you where execution is. All right. So, if we execute one step, you can see we have created a circle instance with radius 0, x, and y, but all these variables are created but uninitialized.
I'm not sure.
Then
Yeah.
we execute these lines of code, populates radius x and y with 10, 100, and 100. Having completed that, we jump to line 10, which is the next line. This little box up here is your output. So it prints the radius. The next line, line 11, you see, modifies radius to 15. Then prints it again. It prints 15. We declare x, which is never used, and we declare hello, which is also never used. Does this make sense?
Okay, so the x and y we declared in main and the x and y we declared in circle are different.
Precisely so. And like that's the beauty of this tool is like you might have
Yeah.
mistaken that.
It explains things.
It explains things. It actually gives you a visual representation. This thing is really, really good.
Can you share the link in the announcements?
Yeah, sure.
Thank you.
You can just Google search Java Visualizer.
That's true, but I'll also share the link. Yeah. So this thing will become, and this is like the default code, but like this is the example. This thing will become extremely useful once we have fairly complicated associations going on. Like there are things I can already point out, if you just give me a moment. There are things I can already point out here, right? Number one, C is a variable contained in the main class, right? It's a variable contained in the main class which connects to a separate area of memory containing all of the circle information. So here's the advantage. Oh, I keep wanting to hit save, you know, but you don't in this.
Yeah,
It's annoying.
I do that too.
Yeah.
All file save,
Oh, okay.
F5.
So, consider this one. We create C1. Now we create C2. We now have 2 circle instances. Are the variable names different?
No.
No. Well,
Exactly. The X property has the same name in both of these instances. The thing that distinguishes them is these things are not allowed to have the same variable names inside the main class. That's how you distinguish between those two versions of X. And that's also how you distinguish between this X and those ones, right? In one case, you have, so to access this one, you say c1.x. To access this one, you access c2.x. To access that one, you just write x, because it's inside the class you're accessing it from. Does that make sense? You had a question?
So are those radius x and y, are those like instance variables?
Yes. So these are instantiated instance variables. These are objects, right? These are the instance variables of those objects. Yes.
But all the objects have the same value, so aren't these values attached to the class instead of the object?
No, they don't. They only have the same values because they haven't been modified from their default state. And in fact, this one has, right? On this line here, c1.radius equals c1.radius plus 5, we are in fact modifying that slot slightly. I just, like in real life, yes, those would all be different values, but because this is very short, this is a short amount of code, I haven't actually modified them. But yeah, the changes are tracked independently. You can put it that way. Question?
If I wanted to be pedantic, could I refer to x as main.x?
Like the question is from what context,
Yeah, okay.
right?
What about this dot x from the main?
This dot x is also not quite true because this is a local variable to the main method. Main is allowed to have its own instance variables, and we haven't talked about what this is yet. So we'll get there. Don't worry about this just yet. There's a this keyword, that's what I'm talking about. We're not there yet, don't worry about it. Okay, so, good. So, exercise time. So, the code you're about to do for this exercise, please keep it for Friday, because we're going to build up an example over a number of different exercises. We're going to keep adding things to the same class, so please don't lose the code once you've done it, okay? Good. So, pick one of the object descriptions below. Draw well, we haven't done the drawing the UML diagram, we'll do that, we'll worry about that when we do methods. So, consider the following scenarios and make a class with instance variables to match the scenario. Number 1, a bank account associated with a customer name, an account ID, a balance, and an annual interest rate, plus whatever else you think would be useful in that class. Scenario 2, a square object which has a location, color, and size, can be filled, unfilled, etc. C, a television, which is an old rectangular implement often found in living rooms of families where they would sit around and watch Law and Order in the before times. A television can be on or off. It can be set to channels from 1 to 1,000. Channels used to be a thing that you would find on televisions, fixed amounts of programming designed by broadcasters, which were meant to be consumed without flipping between channels too much, although people often did that during commercial breaks, and commercial breaks during television are the origin of YouTube ads. So, TVs have 3 possible inputs, VGA, HDMI, and cable. volume goes from 0 to 11, etc. However you want to model that, that's your prerogative. D, a student in some course has a name, ID, 5 grades, 2 assignments, 2 tests, and a final. So do like a student record for a course for grading. Or, of course, the one that probably a fair number of you are going to do. A video game player object has a user ID, location, color, health, etc. If you want to do something a little more creative, that's also fine. Please make a class to represent something with 4 or 5 properties. Okay? We'll give you, I think, 5 to 10 minutes to get that out.
And are we drawing a diagram or are we writing a code?
Don't worry about the diagram yet. We haven't studied diagrams, so we'll do that reasonably short order. Okay? Go, go! Yes?
We're just doing the same thing here, but instead we're going to put up the information for one of those. So like here it's like,
Yeah, just pick
it's
some
like
values.
gonna be like,
We're gonna add
instead
enough
of this will be like
instructors as we go along.
Randy, like a string or something like that. Like,
No, you only have to do one.
double.
For practice? Yeah, do them all. Yeah.
No, I think it's just, we're just messing around with the class object.
Yeah, once you've made all of these, in theory, you could access all of them from the same main class. But for now, let's just, yes. Yeah, yeah, there's actually one more part that I forgot to mention. Okay, one additional requirement. Make a main class with a main method that creates at least 2 of the object that you created and modifies a few properties on them. Right? Basically, just do exactly what we just did for the example with your own custom class. Okay?
And are we creating different classes in different Java files?
Yes, the classes should be in different Java files. If you want to visualize it in the tutor program, you have to not do that, but if you're in IntelliJ, do them in different files. Yeah, that's how it expects things.
For some reason, it's not, I'm trying to close it.
Yours is also taking a while.
How can I cancel it? Cancel it, but
I don't know. Mine is still working on it too. So, I don't know.
but for his, he got.
Yeah? I don't know, maybe like shutting down IntelliJ and restarting it would work. I'm gonna try that. Otherwise, you can always load it up into Python Tutor.
Would it be like customer name in a different class and account, is in a different class and balance?
Sorry, hold on one second.
Yeah, no worries.
Yeah, so like right here, like I have like a string, integer, double, so that's what I'm doing for that.
Okay.
Yeah,
Okay, so you just put it in that class and then you call it.
yeah, and then call it in the main part of it. Yeah.
And you just have it a set variable sign. Yeah.
No
It's just
user
brackets.
inputs. Yeah, it's just
Yeah.
brackets.
Oh yeah, restarting IntelliJ actually cleared the problem, so. notice there's a mismatch between that and that. So if we fix that. And it also, it's case sensitive. Oh, and the file has to be renamed as well. In Java, the file name is expected to be the same as the class name. I see your hand, but that's not convenient to get to you
That's
because of the layout of this room. I will make my way over. Like, the layout is terrible.
Yeah, it's awful.
Like, if you're gonna do this, right, if you're gonna do this layout, you put the podium right here, right? Like, I should be standing right here to give the lesson,
I don't disagree.
right? But instead, they filled the middle with more desks, and it's like, okay, you man, like, if you'd have used that part, you might
The
have,
layout logic is bad, we rewritten.
anyway.
So what is this? Is this the memory location of the object in hexadecimal?
That is the memory location of the object in hexadecimal. Yeah. If you want the contents, you have to call the two
Yeah,
string.
oh yeah, yeah, I just wondered. I'd like to see everything.
Yeah, it's kind of fun. That's like, that is kind of technically what's being compared when you don't use dot equals.
Yeah, okay.
So I'm ahead of program, but if I'm using a constructor, do I still have to initiate the variable before? Because when I use this in a variable, I haven't defined yet. Then it's given, oh, I need to give a class,
So, if you remember our talk about static,
yeah,
um,
I forgot.
That's basically what we're doing, yeah.
this is how you do it for static.
I'm trying to do something a little bit more interesting.
In a static context, the constructor is then called, because the constructor creates objects, and then in a static context, there is no object. But if you have an instance and you have an object, you basically do either.
Well, if,
We prefer you use the constructor.
in the case of the circle, though, when you create an object, it gives you those variables. You create another object, and you change the variable to the first object, and you change it to the second object.
No,
Or are they,
they are, yes, they're separate and independent pieces of code.
is there a way to hive mind all the objects to have like a variable and share them amongst them?
That's a static variable.
That's, okay, so that's, so if I did static on a radius, it would share them amongst them.
Correct.
So,
You can access static from an instance, but not instance from static. So like if the circle class had a static radius property, all circle instances would have access to it. Therefore, it functions as being global to all instances of the class. That's what static means.
but, okay, so if this is because I have the string, and I have string this, something I haven't declared yet, but I want to declare.
I'm trouble calling it.
Are you looking at it?
Yeah, so like how would I call it
Yeah.
over?
Yeah, so like the first thing when you call out a class is you do the name of your class. So I have mine as index right here.
Right.
Index and then the name, I put C equals new and your class name and brackets.
So now it will use the class. Now it knows to use that, right?
Yeah, and then you put brackets, yeah, with that. And that sort of like puts the class inside of this file.
Okay, and then you can
And then-
reference things.
And you can
Do-
reference it, yeah. So then whenever you wanna
Dot.
whenever you wanna use one of these objects here,
Something that
Yeah.
doesn't
you
exist,
do
it's
just
create that thing.
B dot,
the-
whatever the name.
the name of the class, then dot, and then what
Right,
you're
so
trying
let's
to
say I
call.
wanted to call a name, all I have to do, like, this is just.
Yeah, you'll have to do b dot name.
That'd
Yeah.
be like what actually, like, obviously I have to put it in somewhere, but.
Yeah. Oh yeah, you got it.
Thank you.
What about you? You doing alright?
Alright.
What's that?
Yes,
What's wrong?
your number is too long.
Make it look nice. I got my calculated interest. You get very very accurate right here.
Or long.
Right?
Long, that should be long. Is your number too large or long?
Calculate the average, yeah, you calculate them all together and divide by the amount.
Too long. So use a string. Yeah.
I don't need this.
No, you don't need the main part in the,
Sure.
in the class,
Give
no.
it some values.
And also, when you're talking about the person.
Oh, that works. Okay.
Yeah, there you go. Oh, you need your main inside of your main.
I have a question. This one's about client side.
Oh, but like JavaScript?
Yeah,
Oh, okay.
well, this isn't Java.
No, don't worry about
Yeah,
that. That's fine.
Like, you know
Yeah.
how,
I fix.
one of our-
Actually,
one
no.
of
I
our
have a
names has to
I
be
have a
disabled.
script minion that fixes stuff.
Is that for the assignment?
Yeah.
I haven't finished yet.
Because that's
So,
just
okay,
a waste
what's
of
wrong?
time.
You know if you did the disabled part?
The disabled? No.
I
Like
don't know.
here.
I don't know how to do it.
I appreciate that. I really do.
Yeah, hold on. So some JavaScript here. You're
Okay.
trying to,
So I'm going to assume that everybody did okay with that exercise. That you got something that looks kind of like this. Good. Let's move along, shall we? Good. Thank you. So, the thing I would like to show you now, UML diagrams, which of course is a requirement of the assignment. So, if you take a look at the Resources tab, you have two different programs, Draw.io and Umlet, UML-et. I think it's Umlet, but anyway. The one I recommend you use is Draw.io. I think that one's easier to use, easier to find. Draw.io. It's also, you can use it browser-based as well, which is fine. So, if you follow the link, app.diagrams.net, click on where you want to save it to, in my case, local device, create new diagram, there you go. You are presented with a large number of different types of chart. Question? Sorry, can you speak up a lot more than that, please? Yeah, sure. So, step one, on Canvas modules, resources, draw.io for UML diagrams, click link, open in new window. It presented me with a dialog to say where I wanted to save it. I just selected device, which had a picture of a hard drive. So, you know, if you had a GitHub account, you could link it, I guess, if you wanted to.
Or your OneDrive.
Yes. Connect, or create new diagram. You will see there's a large number of different types of charts. So, let me complain about UML for just a moment. All right? UML stands for the Universal Modeling Language, right? So it's supposed to be a universal modeling language. How is it universal if there are 10 different types of charts? It's not universal.
Maybe those are the two most common?
Yeah, that's actually the problem with UML is like it's not very strictly defined, and it's like everybody has their own way of using UML, which completely defeats the idea that it's universal, you know? So it's not the universal modeling language, it is a ML, it's a modeling language. Don't get me wrong, it's useful to have a modeling language, but it's kind of like, you know, it's
But
like,
everyone speaks a different dialect.
yeah, it's like, you know, the Miss Universe competition? How do you know? How do you know that you're Miss Universe? You don't know everybody else in the universe. It's ridiculous. That's what I feel about UML. Anyway, so you want class diagram because we're doing classes.
Why don't you just call it universal modeling language?
I mean, I just had that whole rant about how it's not useful to call it universal.
Just call it useful modeling language.
Oh, useful modeling language? Yeah, I guess you could call it that.
Just another U word.
Yeah.
Anything but universal.
So this is a class diagram. There's a lot of stuff going on in this diagram that we haven't learned yet. So let's just delete the whole thing. Delete. So, to create class diagrams, there are two main components. Number one, we've got boxes. Number two, we've got arrows. For the moment, let's just learn how to use the boxes. So, if you, on the sidebar here, this is like all of your symbols that you can drag and drop, right? One of them's a bad actor. The other one is a Shakespearean actor. Drama teacher. Only a drama teacher. Which is why he's only good at creating drama. Ha ha ha. So,
His Halloween skills are top notch.
UML, sorry. So, under the UML tab, you've got a bunch of different types of boxes. For us, you'll want the one that has 3 sections. This one. Just click and drag it over. You'll notice that it has an area for fields and an area for methods. We haven't done the methods yet, but we're gonna very shortly. And there's basically no UML diagram you're going to make in this class that doesn't use methods. So we'll just start with that one. So you change the class name to whatever the class is that you're modeling, right? In this case, circle. This should match the class name in Java, and it should match the name of the file. Each of these rectangles is going to be a different file in your project. All right? So, you change that to circle, and then you change your fields. The plus means public. Minus means private. So, it's literally an exact translation of what you've got in your code at this level. Where are we here? There we go. So we've got a public radius of type double. All right? And if you press enter, you'll find that it doesn't behave the way you want it to. It's a little dumb, but right here, very, very tiny, there is an item attribute widget. You have to click and drag that into the UML diagram instead of just pressing enter like would be normal. And I know I recommended this software, but you know, the other one is worse, if you can believe that. So you just click and drag your item attribute, and it adds a new one.